yet another class. I'm Dr. B, your chemistry teacher. Today we are going to be looking at hydrocarbons, saturated hydrocarbons. So we'll look at saturated hydrocarbons, saturated hydrocarbons, saturated hydrocarbons. Now, it is important for us to know that we also have unsaturated hydrocarbons, but that is going to be a topic for next time. But today we are going to look at saturated hydrocarbons. But what do we mean by the term hydrocarbons? Virtually everything you find around you is made up of hydrogen and carbon, and provided it is made up of hydrogen and carbon only, then we classify that as hydrocarbon. Of course, the term hydro is from hydrogen and carbon is from carbon. So simply put, we could just say organic molecules that are made up of only hydrogen and carbon are described as hydrocarbon. Do not forget that organic molecules that are made up of what? Hydrogen and carbon only are classified as hydrocarbon. But what is saturated hydrocarbons? Saturated hydrocarbons are simply hydrocarbons, or rather organic molecules that are made up of only hydrogen and carbon but are only bonded by single bond. Do not forget that, very important, that saturated hydrocarbons are bonded. They are bonded by only single bonds. They are bonded only by single bonds. That means that if these particular organic molecules are bonded by more than just one bond, they are no more saturated hydrocarbons. They are perhaps unsaturated hydrocarbons. So while we understand the fact that hydrocarbons are simple organic molecules that are made up of only hydrogen and carbon, we must also understand the fact that saturated hydrocarbons are simply organic molecules made up of hydrogen and carbon only and bonded by just single bonds. The only single bonds is the principal characteristic of what? Of a saturated hydrocarbon. Do you also know that saturated hydrocarbons, beside the fact that they are bonded by single bonds only, their bonds are covalent in nature? That apart from this, saturated hydrocarbons have covalent bonding, or possess covalent bonding. So every saturated hydrocarbon possesses a covalent bonding. That is one of those characteristics. And again, we must understand that saturated hydrocarbons also have a tendency of having their own carbon atoms being bonded to a maximum hydrogen bond. So their carbon atoms, that is one carbon atom, is bonded to a maximum number of hydrogen atoms. And let me say that usually carbon atom has to bond to at least a maximum of 4 different hydrogen atoms, and this is to allow it to arrive at an octet state, to allow it to arrive at a stable electronic configuration state. Now, if it is not bonded to 4, then it is going to be unstable in terms of its existence. So if you look at saturated hydrocarbons are bonded by only single bonds. They have covalent bonding as their own type of bond, and then their carbon atom is always bonded to a maximum number of hydrogen atoms, and usually it is 4 hydrogen atoms. Now I want us to also know that saturated hydrocarbons can be divided into two different parts. So, saturated hydrocarbons can be divided into alkanes, and cycloalkanes. Okay, so saturated hydrocarbons can be divided into alkanes and cycloalkanes. Usually, alkanes are described as aliphatic. They are described as aliphatic. So, alkanes are always known as aliphatic hydrocarbons. Do you also know that these saturated hydrocarbons usually possess a structure that is ring type and a linear type? Now, these alkanes that you see here can be linear and can also be branch. So we have linear alkanes and we have branch alkanes as well. Alright, and then we have the cycloalkanes. And in some versions of the textbook, they could tell you that saturated hydrocarbons are divided into three: linear alkanes, branch alkanes, and cycloalkanes. But you need to understand that the linear alkanes and branch alkanes belongs to alkanes only. Cycloalkanes is a different type of saturated hydrocarbons. But what are these alkanes? Okay, so alkanes are usually described by the fact that they possess what we call the saturated hydrocarbons formula. Okay, that defines them. Usually, you have alkanes from a long chain where you talk of methane, ethane, propane, butane, and so on, to hexane, to heptane, to octane, and thereabout. Alright, those are all alkanes, but however they are being bonded by just a single bond. Now, let us take a very quick look at these examples of alkanes. Now, I want us to know that for alkanes, if they are branch alkanes, that are branch alkanes, can be, let's say, you could have this. Okay, this is a branch alkane. Alkane that is linear can just be this. Okay, so where these are the various carbon atoms, and then the hydrogen atoms will get attached to them. But let us take something practical to understand what we mean. Do you know that when you write this, which is CH4, and this is methane, that this is a type of alkane. It's not a branch alkane, but this is a type of alkane. Do you also know that when you write this, that this is also another type of alkane, okay, and this is propane, okay, and that when you write this, okay, and then there's hydrogen, okay, hydrogen, and hydrogen, that this is butane, and that this is a branch alkane. Okay, this is a branch alkane. This is butane. You can see 1, 2, 3 serially wanted to be a linear alkane, and then it now has a branch of a methyl group down here. So this is a typical alkane, but what a branch alkane. So alkanes can be linear. They can also be what? Be branch. Now, if we were rather looking at a typical cycloalkane, which is also another type of saturated hydrocarbon, that is